Hello, today we're going to be talking about maize hybridization. You might know maize as corn. Start off with the table of contents. We will be looking at a topic choice and explanation, an introduction to maize, some of the history, the genetics, changes to yield and production, and then a conclusion. So get ready to learn a lot more about maize. So to start off, my name is Emily Ruiz. I am a second-year agriculture education student here at Chico State. And the topic that I chose is how do they hybridize corn and what are some of the outcomes of this process? In the bottom corner, you can see myself as a child enjoying some corn at my county's fair. I have always enjoyed the crop corn, and so this topic was really interesting to learn about. To start off, this is an introduction to maize. As you can see, it is a Central American cereal plant that yields large grains set in rows on a cob, corn. In the middle, you can see more of the classification of this crop. And then in the pictures, you can see what it looks like as a plant on the cob, some kernels, and what it would look like in a field. This next image kind of shows you more of the different parts of this plant. Next up, we're going to look at some history. Starting off with a timeline, about 10,000 years ago in southern Mexico, teosinte was first domesticated. Looking at this image, you can tell that this crop is very different from what we know as corn today. It has come a long way, and you can see the changes in shape, size, and everything about it is different. Next up, you'll see in 6,000 years ago in the Americas, modern maize was first cultivated. Then in the 1500s to 1600s, the crop was finally carried overseas through trade routes, mainly in Europe. Now there are over 700 different known varieties of the crop worldwide. Some other important times and names would include George Scholl being the first person to start the scientific research on corn hybrids in 1905. Then it wasn't until 1917 and 18 that Donald Jones founded the double cross hybrid. And then it took until 1921 for this cross to go to market. Years later, in the 1960s, is when the single cross was finally commercialized. This image shows these developments and the increases in yields correlating with these discoveries. So next up, looking at the different kinds of hybrids, I will focus on the two most important ones, which is the single cross and the double cross. Before looking at those, it's important to know what an inbred is in comparison to a hybrid. So if you look at this picture, you can see that inbreds are when you take the same plant and you're kind of breeding it over and over again, but through this process, the plant loses its plant vigor, and then it isn't as good of a plant. So when you're introducing hybridization, it brings back that vigor and produces a larger, healthier plant. Now that we know that, let's look at the single crosses. So a single cross is when you take two inbreds and cross them together. That's a single cross. And then a double cross comes from 4 different inbreds, making 2 different single crosses. And those single crosses are going to be crossed again to make a double cross. Some of the other crosses would include a modified cross, a 3-way cross, a top cross, and a varietal cross. All of these crosses serve a different purpose and is done differently. So next we're going to look at some advantages and disadvantages about hybrid. So as you can see, you'll get higher yields per acre with hybridization, and then the crop will look more uniform with the rest of the products, and they will be it'll be a more quality plant in size and shape and vigor. Some of the disadvantages would include expenses that come with purchasing these hybridized seeds, and then you can lose some of your income if you don't have the proper environmental factors like land or location. And then another biggie would be the vulnerability of these plants. If one of them gets a disease, every generation after that would have the same disease. So you can't replant these, and then that'll add on to your lost expenses. Next up, we're going to be looking at genetics. First up, transmission genetics, which I like to think of as an individual level genetics. Some of the mechanisms at this level that are used would be self-pollination. These are monoecious plants with both female and male parts, so they can pass on genes naturally. Then there is hand pollination and crosses, which will be the conscious decision to pass these certain traits on from a specific parent plants to make that better crop. Second up would be molecular genetics, which to me is looking at the cellular level. So corn is monoecious, and so it can be duplicated when producing a plant on its own. But when you get farmers and scientists hybridizing them, they'll use any of the 3 genomes, which is nuclear, mitochondrial, and plastid, to insert specific genes that will provide desired traits. Another fact about the maize genes would be that there are many transposable elements that can produce mutants, but they can also get rid of mutants depending on the processes that these scientists take. Next up, we will look at population genetics, which is at the population level. Like how we learned in the part about inbreds, after generations and generations of replanting and being self-pollinated, the plant will lose its vigor. But when you introduce these hybrid crosses, it'll revitalize the plant vigor and in turn produce improved varieties, whether you're looking at uniformity, yield, shape, size, color, etc. Next up, we'll take a look at changes in yield and production methods, starting off with different biotechnology. We'll look at genetic engineering, in which you can use gene mapping and genomics to insert specific genes to improve the crop. In lecture, we learned about plasmids. So here's an image looking at foreign genes being inserted into the corn genome to improve the crop. Then let's look at plant breeding, which is when you're picking and choosing which traits are desirable and which are not. This image shows some of the cutting in the DNA and then putting it back together to make that better crop. Next up, we will be looking at DNA sequencing and gene marking. You want to keep track of the gene pool to ensure that the crop will be able to keep producing for generations and generations. This image just demonstrates some of the markers that they put in to change the outcomes of the product. All right, heterosis is next, which is creating a better generation of plants than the parent plants. In corn hybrids, we see larger plants. You can have pest and disease resistance. You can have higher protein levels, increased oil content. We'll see higher yields per acre, an increase in vigor, which is the main part of why they hybridize corn. And then we'll see more uniformity and more maturity in these crops. Lastly, let's look at some of the trends for corn. About 1.2 to 2.4% is the rate of improvement in crops of corn per year. Looking at this graph, you can see a steady incline from when they discovered this technology. Looking at yields, you can get about double or more quintals per acre when you hybridize the corn. You'll have about 40 quintals per acre when you hybridize compared to the 10 to 20 quintals per acre without hybridization. Another point to know would be that even though this is a year-round crop, a warm and tropical climate is needed. This crop does not like frost and will fail in those conditions. So lastly, for my conclusion, I felt it was important to note that hybridizing maize has had a significant impact on generational progression in the corn crop, and that these discoveries have influenced genetic variety by using the different cross styles. Scientists are still finding new ways to make the next generation better, and so the future of this crop looks bright. Since we've learned what has already been done to improve the crop in vigor, size, yields, etc., I know I read that they are working on making the crop drought resistant, so that will be a great new improvement. Here are the 11 different sources that I used to complete this research, and each of the images that I used were linked on their slide pages. So thank you so much.